Okay, so starting out, lecture 32 through 34, part 6, this is solving systems of nonlinear equations, okay? So if I look, a couple examples of some nonlinear equations. My first one here, y minus x squared equals -1, y plus x equals 1. Here I've got an example where I've got a parabola and I've got a line, okay? So some nonlinear there with the parabola. Here I've got a circle, x squared plus y minus 2 squared equals 25. And then I've got a line that we're going to deal with. And then my last one over here, I've got a circle and another circle. Okay, so dealing with our nonlinear equations, honestly, the best way to solve these is to do substitution. If I'm trying to do elimination, like with this equation here, I've got x squared and x. I'm not going to be able to eliminate my x's without just causing some massive confusion going on. I'm not saying that you can never use elimination. Like over here, I could use elimination and eliminate my y's. But honestly, for the most part, the best way to handle these is by doing substitution. Okay, so to go ahead and solve this one then, I'm going to want to use substitution most likely. Okay, and usually the one you want to substitute with is your one that is in the linear form. So I've got a y plus x equals 1. I want to solve that for y. I don't want to solve it for x because then I'm going to have to plug it into an x squared and I'm going to have to square some things. It would work, but it's just going to be easier if I solve for y and plugged it in. So I'm going to need to subtract x to both sides. It's an x, sorry. And I get y equals negative x plus 1. So now I need to take this negative x plus 1 and I need to substitute that into the equation. So instead of a y minus x squared, I'm going to have a negative x plus 1 minus x squared equals negative 1. Now I need to solve this for x. But in order to do that, I've got an x squared and an x. So the only way that you can solve with an x squared and an x is by factoring. And before I factor, I have to make sure that it equals 0. Okay? So I'm going to need to make sure that I add 1 to get that over there so that equals 0. I've got to add 1 over here. Okay, then I'm going to want to put it in standard form. So I've got my negative x squared first. Then I've got my minus x. Then I've got my plus 2 equals 0. Okay, so I'm ready to factor. Actually, not quite, because there's a negative in front of that x squared. And remember, if there's a negative in front of the x squared, our factoring that we do won't work. Okay, so I actually need to take everything on here times the negative 1. Gives me a positive x squared plus x minus 2 equals 0. Now we're ready to factor because we don't have a negative out in front. Okay, so when I factor this, 1 times 2 gives me 2 factors of 2 that subtract to give me 1. We go through our factoring steps, and I end up with an x plus 2 times an x minus 1 equals 0. Set both of those factors equal to 0, and I end up with x equals negative 2 and x equals 1. Now, I don't know if you guys have picked up on this yet, but when we're solving for systems of nonlinear equations, you may not have one point where they intersect. And in fact, in this case, we're going to have 2 points when they intersect. So I found 2 different x values. So now I need to find the y value for both of those. And I'm going to need to plug it back into one of my original equations. Probably want to plug it into the linear one so then I don't have to deal with any squareds or anything. So when I do that, I get y plus negative 2 equals 1. I'm going to need to add 2 to get rid of that. Add 2. And I get y equals 3. So that means the point negative 2, 3 is a point of intersection. Then I'm going to go y plus 1 equals 1. For that, I'm going to need to subtract 1 to both sides. Actually cancels both, and I get y equals 0. So that means the point 1, 0 is one of my points. So I used my substitution to solve. This has 2 points of intersection. Okay? Now, just like our examples before, they're going to ask you guys to graph these to prove that. Okay? So let's go ahead and go to the next slide. Let's graph to prove that these are in fact our answers. Okay, so what do I need to do to graph these things? Well, put them in y equals form, right? Isn't that how we usually graph them? So for this one here, I would need to add an x squared to both sides. That gives me a y equals, let me put that in red, gives me a y equals x squared minus 1. Okay, so that's my parabola parent function that's just been shifted down 1. So instead of 0, 0, I shifted down 1. Instead of 1, 1, it shifted down 1. All of our points have just been shifted down 1. So there's my parabola parent function. Okay. Then I need to graph my other, and again, just get it into y equals form. So subtract x to both sides. When I do that, I get y equals negative x plus 1. So that's got a y-intercept at 1. And then it's got a slope of negative 1. So I can go down 1 to the right 1. Oh, there's a point of intersection. I could go up 1 to the left 1. And I can follow that pattern either way. And we can see it's going to intersect again. So we're graphing to prove that our two answers that we were supposed to get are correct. And remember on the last slide, the two answers we got were negative 2 and 3, which I see negative 2 and 3. And they were 1 and 0. And I see 1 and 0. So we have now graphed and proven that our two answers were correct. Okay, now for this one, we've got a circle and we've got a linear equation. Now, I'm going to want to solve my linear equation for either x or y. Honestly, x or y, it doesn't really matter. If I solve it for y, I'm actually going to end up with a little bit less work. Okay, so I'm going to go ahead and solve this one for y. Basically, I'm only going to have to do one example where I have to do a FOIL. Okay, that's why I'm going with the y. So that's going to give me a y equals negative x plus 7. Okay, so I've got y equals negative x plus 7, and I need to substitute that in for y in my equation. So when I do that, I've got x squared plus, and then in parentheses, instead of a y, I've got a negative x plus 7 minus 2 squared equals 25. Okay? So I've got a negative x plus 7 minus 2. So really, I've got x squared plus a negative x plus 7 minus 2 gives me a positive 5 squared equals 25. Okay? Now, before I go on, negative x plus 5, I cannot distribute that squared in. Okay? I do have to FOIL that. So down over here to the side, I'm going to show my FOIL work. Okay? Negative x plus 5 times negative x plus 5. Okay? Negative x times negative x gives me x squared. Negative x times 5 gives me negative 5x. 5 times negative x gives me negative 5x. 5 times 5 gives me a positive 25. And I end up with x squared minus 10x plus 25. Okay? So I've got, again, x squared plus, and then I FOILed. And when I did that, I got an x squared plus 10. Whoops, started to write a 2. Plus 10x plus 25 equals 25. Okay? Now, I've got an x squared and an x. The only way I can solve with an x squared and an x is I have to factor. And before I do that, I have to make sure it equals 0. So I'm going to want to subtract 25 so that it cancels on this side. I'm also going to want to add my x squareds together. When I add my x squareds together, I get 2x squared plus 10x. And then I have a positive 25 and a negative 25. Oh, those canceled too. Okay, so really all I have is a 2x squared plus 10x equals 0. Now I still have to factor to solve this. So if I'm looking to factor, I see that both of these terms have factors of 2 and x. So I can pull a 2x out in front. That leaves me with an x plus 5 equals 0. Okay, set both those factors equal to 0. I get 2x equals 0. Divide both sides by 2. I get just x equals 0. Then I've got an x plus 5 equals 0, which gives me x equals negative 5. Okay, just realized I made a quick little mistake here. should be minus, okay, which is going to end up making that be minus, okay. Copy that down wrong. It's x squared minus 10x, okay, 2x squared minus 10x. So when I factor out that 2 and that x, that leaves me with an x minus 5 here, which ends up giving me an x equals a positive 5. Okay, so again, I found that my x equals 0. I found that my x equals 5. Okay, so I know x equals 0, x equals 5. That means that I need to plug those back into one of my originals to find my y. So first one, I've got 0 plus y equals 7, which is going to give me just a y equals 7. So the point 0, 7 is one where I'm going to intersect. And then I need to plug in a 5 for my x, which is going to give me 5 plus y equals 7. Subtract 5 to both sides, and I get y equals 2. So the point 5, 2 is also present. Okay, so let's graph these things just to prove it. I don't need to do anything to my circle to be able to graph that. That's already in our form. Okay, remember, if I have just an x squared, that means that my center value is 0. And if I have a y of negative 2, it's going to be a positive 2. We change the signs. Okay, then I've got 25 for my radius squared. So that means that my radius is actually 5. So I'm going to go up 5, to the right 5, down 5, to the left 5. Okay, draw my circle. Sorry, I'm trying to go fast here. It's not the best circle you've ever seen. Okay, then I've also got to graph my other line, which I just need to get y by itself. So subtract x, and I get y equals negative x plus 7. It has a y-intercept at 7 and a slope of negative 1. So I can go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And we can see through our graph that there are 2 points of intersection. One is at 0, 7, and the other is at 5, 2. So again, we were able to graph to prove our answers. Okay, next problem. Okay, last problem I have here, I have 2 different circles. When I'm going to solve this one, I'm still going to use substitution, but I'm going to save myself a little bit of work. I'm not going to just solve for x. Okay, I'm going to use this top equation here, and I'm going to solve for x squared. So I'm going to say that x squared equals negative y squared plus 9. Okay, now when I do that, I'm saying that x squared equals that, which is fine because I have an x squared over here by itself already. Okay, so I can solve this then. It's a negative y squared plus 9 plus y minus 2 squared equals 1. Okay, so I've got my negative y plus 9 in here for my x squared because I found that x squared equaled that number. Now I just need to solve. We've got to have some FOILing steps. Negative y squared plus 9 plus y minus 2 squared FOILs to y squared plus, minus 4y plus 4 equals 1. Okay, I've got a y squared and a y. I'm going to need to solve it. Oh, wait, I've got a negative y squared and a positive y, so those two actually cancel each other. What I really have is I have a negative 4y plus 13, because 9 and 4 gives me 13, equals 1. And now I just need to solve. Subtract 13, I get negative 4y equals negative 12. Divide by negative 4, I get y equals 3. So this one's only going to intersect at one point, okay? So I need to plug that back into one of my originals. X squared plus 3 squared equals 9. X squared plus 9 equals 9. And I get that x squared equals 0. Square root both sides, x equals 0. So the only point that this intersects is at 0, 3. Okay, I'm running short on time, so I'm going to try and graph these really quick. First one, x squared, y squared, center is at 0, radius is at 3. Okay, so up and down 3. Next one, I've got an x at 0 and a y at 2. Okay, it's got a radius of 1. So what I have here is I have a circle inside of another circle, and their only intersection is that top point right there. which that top point is 0, 3.